So, where we left off from last day was example 8. I wrote continue on Monday. Let me erase that. Oh, and I'm going to say I like example 8. I like example 8. I like example 8. Example 8 is a nice question. I like number 8. 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 It says, consider a 6 kilogram mass sliding up a rough ramp. This bugs a lot of kids. Mr. Dueck, how can it be sliding up? Let me show you. So it is possible to be sliding uphill. You're just not going to slide for very long. It is possible to be sliding downhill and come to a stop. That would just mean that friction was bigger than the component of gravity pulling you down, and you'll come to a stop. I'm going to dulp. I need to draw a little picture. So here's my ramp. Here's my block. Here is the angle of 32 degrees. Whoop. Flashback has opened a browser. Oh, it just did an update. Give me a second here, folks. Sorry. We'll get interrupted again, but that's okay. Hey, look at the block. What are the forces acting on it? Get the obvious ones. Hello? What are the forces acting on this block? Get the obvious one. Okay, so, and I'm going to draw gravity nice and big. I'm going to change colors, though. There's mg. What else? There is a normal force. Yoink. And I can tell you how long it's going to be. The distance from here to here is going to be roughly the distance from here to junk, about there. So I kind of eyeball it. What else? Is there friction? Yeah. Which way is the block moving? Up. So which way is friction? Ah. Friction. If I asked you, Neve, for the free body diagram, that's it. This didn't say, though, draw the free body diagram. So I'm going to add the components, but components normally don't go on a free body diagram. But I'm going to break gravity up, and I'm going to break gravity up into its perpendicular and parallel components. Oh, and this angle here is the 32 degrees. We did our little proof, and we said if we all draw it that way, we'll be good. Now, I like example 8, I like example 8, I like example 8, except I would have no problem just giving you example 8D and not having you walk through all the other stuff, expecting you to clue in, well, if they want me to find how far that's a distance, I've got an initial velocity, V final is 0, I need to find acceleration or time or something. Oh, acceleration would make sense. Anyhow, Mike, what is A asking me to find, Michael? Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which force is the same size as the normal force? And don't you dare say mg, because it ain't. Ah, so this is going to be mu mg perpendicular component. What's the perpendicular component? It's either sine or cosine. If you're looking for another way that you can remember, for what it's worth, if you start labeling this triangle, that's hypotenuse, that's adjacent. Which trig function is hypotenuse and adjacent? Cosine. It's cosine. So this is going to be mu mg cos theta. I haven't bothered memorizing that, although I do remember that 2 lines is sine. I guess I sort of have. But I only did that this last year when a student came up with that dumb way to remember. Michael, what's mu? 6, 9.8 cos of 30. $32, sorry, not 30, $32, Mr. Dueck. fix that in my notes. Do you get 4.9865222? I'll go 4.99 newtons. Well, I'll write a few extra sig figs. 4.9865, because I'm going to use this. 4.99 newtons. Is that right? Anybody else? Yeah? Okay. I'm in a slump today, so just warning you. I'm making mistakes left, right, and center. Hakeem, what's B asking me to find? Your name is Hakeem, right? Oh, yeah, it is. Acceleration. Okay. I could use my answer from A as friction, but if they ask me to find the acceleration, I kind of like to do it in one fell swoop because I can better see how everything goes. So looking at my free body diagram, Hakeem, who's winning? Which way is this accelerating? Down the hill. So anything down the hill is going to be winner. Anything up the hill is going to be loser. Is there anything pointing up the hill? No loser. How many forces are pointing down the hill? 2. Which ones? You're right. mg parallel and it's going to be winner plus winner. Most common mistake I've seen on this question is kids want to put friction pointing in the opposite direction. They want to go mg parallel minus friction because they're so used to friction slowing it down. Yeah, if it was slowing down, it was going down the hill, it's going up the hill. So it's going to look like this. mg parallel plus friction equals ma. And although I know that friction is 4.9865, I'm going to do this algebraically because I think some nice stuff comes out of here. I'm not going to plug in numbers. I'm going to say to myself, okay, mg parallel, that ends up being mg sine theta, sine 32, plus friction ends up being mu m, well, it's mu times the normal force. I don't know the normal force. Oh, but look. I know another force same size as the normal force, mg perpendicular, which is mu mg cos theta. That equals ma. Sam, do you see why I wanted to write this all out? What happens to the masses? Get one on everything. In fact, I already got the A by itself. Now it's going to be plug and chug. A is going to be G 9.8 sine 32 plus mu 0.1 G 9.8 cos 32. What's our acceleration? You get 6.024 blah, blah, blah. I'll go 6.0243, and then I'll round off. What did I say, 6.0243? Which Jordan is really 6.02 meters per second squared. Is that right? Anybody else? Yeah? Okay. There you go. Oh, we're not done yet. Alex, what does C want me to find? Oh, by the way, I sent you all an email update on the weekend. You guys got a 4-day weekend coming up? Let's say if by Wednesday you're still missing more than 2 assignments, so 3 or more assignments, I'll get you grounded for the 4-day weekend. And a nice, lovely email. Get your homework in. Yeah, that's how I roll. Didn't mean me. Sorry, what'd you say, Alex? T. Okay, now we're back to last unit. We're back to vector land. We're back to where we were always the same with our directions, as opposed to here when we sometimes let up be negative and down be positive. So I'm going to write T equals And I'm going to defic. Oh, did you say time to what? What's V final? Yeah. Did they give me V initial? What? 20? Oh! And what did I just find? What's the acceleration? Nope. Are we slowing down or speeding up? And we're in our previous unit where we had to take that into account. How do I show slowing down? Negative. Oh, that's not too bad. Can you find an equation that has T, VF, VI, and A in it? And then, Alex, get the T by itself while we're on the topic. Good for you for getting out your yellow formula sheet. Yep. So it's going to be 0 minus 20 all over negative 6.02. Alex, what are we finding? Time, scalar or vector? Now the nice thing is, if you forgot to put the negative in for the acceleration, you would go 0 minus 20, and if you just went divided by answer instead of dividing by negative answer button, there is a built-in error check, because what will your time value end up being? And hopefully you'll clue in time. I've goofed somewhere. The only problem is your new answer stored on your calculator won't be accurate. You can't just use the answer button again. You'll have to retype the acceleration equation, or you can just use 6.0243, which is why I wrote those extra few digits down. Anyways, I did catch it. It had to be negative, so I'm going to do it right all in one fell swoop. And it looks like 3.32 seconds. So that might be a nice question. I wouldn't ask you part A, part B. I would jump you straight to part C. Or, Petra, I wouldn't ask you part A or part B or part C. I would jump you straight to part D. Petra, what's part D asking me to find? Why, that sounds like it's asking me to find displacement. Yes? So, Petra, I'm looking for an equation. It has to have a D in it. Using VF and VI, and either A or I could use time. Although, you know what? Let's use acceleration, because I was very careful on that one there. Is there an equation that has distance, acceleration, VI, and VF in it, my angel? I can use that, but I'm going to avoid using time, just in case I got C wrong. Is there another equation that has VI, VF, A, and D in it? There is. Okay, get the D by itself. So are we looking at the VF squared equals VI squared plus 2AD? VF squared equals VI squared plus 2AD? Yeah. The fourth one, right? In our kinematic section? Yep. Can you get the D by itself? So what's the, I think there's going to be a VF squared dropping down like a domino, and then minus VI squared, yes? Did you say divide by 2A? Yeah? Okay, sorry, I can't hear you. I see your lips moving and that's it. Oh, let's plug and chug. Via 0 squared minus 20 squared all over 2, and I got to put a negative because we're slowing down. 6.0243. I'll use the extra sig figs just so I'm a little more accurate. 0 squared minus 20 squared, all divided by 2 times negative 6.0243. By the way, did I end up above or below from where I started based on how you read this question? Above, so hopefully I kind of get a positive answer. Do you get 33.2? Yeah. Mr. Dueck, this thing slides really, really far. That's because I made mu really small. It's not a big angle. And 20 meters per second, that means it's crossing more than this room every second. It's hauling to begin with, right? 20 meters per second is about 60 kilometers an hour, give or take. Actually, about 70 kilometers an hour. So I gave it some oomph. It'll slide for a while, but it'll come to a stop. Would it then come sliding back down? I don't know. For it to come sliding back down, mg parallel of gravity would have to be bigger than friction up the hill. I could crunch that, but eh. So that was the last one. And then I gave you some questions from the homework. Normally I would say I'll take questions, but today's lesson is just a continuation of inclines, and so it may actually help you clarify and wrap your brain around what's going on. So lesson 7, advanced inclines. I have a feeling I won't get through this whole lesson today either, but that's okay. We'll get as much as we can. How much force is required to pull this mass up the frictionless ramp at constant speed? What would be a good set of words to underline in this question that are really going to be important for me to answer this properly? Constant speed. That's one of those physics phrases that I want to make sure, Alex, that I noticed. Because what does constant speed imply? No acceleration. What does that imply? What's my overall net force going to be then? I can tell you, my equation is going to be winner minus loser plus winner minus loser plus winner equals 0. It's going to be equals 0. All I got to do is get all the winners and all the losers. It's a tie. What are the forces acting on this 7-kilogram block? Get the obvious one. What else? And the normal force would be about like that. And it would be about that long, because it's the Newton's third law to mg perpendicular, which I can kind of visualize. What else? Is there friction? How do you know, Ashley? It says frictionless. Okay. What else? You could call it force applied, but traditionally we've used a different name for a rope or a cord or a string force. Tension. Race, that's it. That's the free body diagram. And if that's all they asked for, good. They didn't say just draw the free body diagram. They want me to figure out how much force. Now let's break this into components. So I'm going to have the perpendicular component and the parallel component. And by the way, normal force and mg perpendicular, these two guys, what is that for you guys? These two guys, it's a tie. How do I know? Because it's not sinking into the ramp like quicksand, and it's not flying into you like Superman. But Claire, what phrase did we underline? It's a tie down the ramp, up and down the ramp too. What two forces are the same size in this question? What two forces are the same size in this question? What two forces are the same size? Tension and what? Thank you. Sorry, I thought I heard you say tension and mg. I didn't hear the parallel. I was going to freak. You know what, Ashley? I think the equation that we're actually going to solve here is tension equals... That's the force. Now, I can't find tension, but I can certainly calculate mg parallel, or as I like to think about it, mg two lines. Oh, that's 40 degrees right there. How can I find mg parallel? What is that? Oh, so tension is just going to be mg sine theta, which in this case is going to be mg 7, G, 9.8, sine 40. Mr. Dueck, I thought the mass is always canceled out. No, not in this case. And I think that makes sense. Wouldn't it require more tension to haul something heavier up a hill? Not very hard to haul a small child in a wagon. Much tougher to haul a pickup truck. Yeah. You know what? Okay. It's going to be 7 times 9.8 times sine 40. Do you get 44.1? Anybody else? Yep. Tension equals 44.1 newtons. Hey, what if there was friction? Which way would friction be pointing? I heard two answers. Someone said up, someone said down. Which one? Which way is the block moving? Up the hill, so which way is friction? Opposite direction of motion. You know what? I'd have another, it would be, tension would have to be canceling out mg parallel and plus friction. Friction is what times what? Mu times the normal force. I don't know the normal force. Oh, but look. I don't know the force. You know what? I could deal with that. If you gave me a mu, I could deal with that. And tension would get bigger. Well, of course it would, because now not only are you pulling the block up, you're having to overcome friction as well. Of course it would. Oh, thank you. I was going, why didn't I do a friction example? And then I didn't realize I did do a friction example. Suppose mu equals 0.65. How much force is required now? So I think now we would have this. mg down, normal force, tension, friction. That's your free body diagram. That's your free body diagram, which I would then break up into components. Is that okay, Josh? Oh, and then, Josh, I would say it's a tie, constant speed, so tension is canceling out down the hill and plus down the hill. I would say tension is canceling out mg parallel, which we already said was mg two lines is sine, plus friction is mu times the normal force. I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which one is the same size as the normal force? mg perpendicular. Which I think, Hakeem, we said was mg cos. So if I hear you correctly, and I think I do, you're saying that tension is going to be mg sine theta plus mu mg cos theta. Is that okay? Tension is going to be, what did I say the mass was? 7 times 9.8 times the sine of 40 plus 0.65, that's a pretty high coefficient of friction, times 7 times 9.8 cosine of 40. Seven times 9.8 times the sine of 40 plus 0.65 times 7 times 9.8 times the cos of 40. You get 78.3? 78.3 Newtons. By the way, when is friction at its maximum? When is friction at its biggest? When you're level. You know how I know that? Because if you go dead vertical, so now you're hanging, how big is friction? 0. The other way I know that is if I put a 90 degrees in for theta right there, the cosine of 90 degrees is 0. This whole term would cancel, and then I would say, oh, tension is mg sine theta, sine 90. Oh, and the sine of 90 is 1. In fact, what you'd be saying is tension is just mg. You're hanging! That all pops out of there. That's actually physics 11 in disguise. It's really, you could argue that that's physics 11 in disguise. Oh, and when is tension 0? When you're flat and level, if you put a 0 degrees right there, you'll find the whole tension, the whole mg term vanishes, and all you're pulling against is friction. Everything else, somewhere in between. Somewhere in between. Example. Okay. 2 objects are connected as shown. So now we've sort of got an Atwood machine, kinda, but with slanties. M1 is 12 kilograms, sits on a horizontal surface, has a coefficient of friction of 0.17. It says M2 is frictionless. Okay. Suggestions. Suggestions. Free body, or you know what, since they gave us a lovely picture, let's just label the diagram that they gave us. What are the forces acting on mass 1? Get the obvious one. Is it sinking into the ground like quicksand? No, there's a normal force up. What else? What else? Tension. And by the way, Jordan, when you said friction, I made an assumption. I looked at this and I said, look, there's no way it can be moving to the left. Either it's moving to the right, M2 is winning, pulling it down the hill, or friction might be so big that it doesn't move at all, but I'm going to assume M2 is pulling it down the hill. And I'll know if I guessed wrong, Manisha, when I solve for the acceleration, if I get a negative. In which case, I'll have to revisit the question. I'll start at the beginning and redo my assumptions, but okay. Hey, what are the forces acting on mass 2? Give the obvious one. Gravity. What else? Normal force number 2. What else? Tension. What else? Friction? No, but would it be much tougher if I had added friction? You'd say, I think it's moving down the hill. I'm pretty sure friction is pointing up the hill, and so you'd point to force up the hill. Call it friction. Components. M2G perpendicular, M2G parallel. Vertically or perpendicularly, everything's balanced. In other words, Nate, these two cancel each other out. They're the same. These two, this one and this one, cancel each other out. So I'm not going to bother writing a perpendicular, or you can think of it kind of as a vertical force equation. They're going to cancel. What I am going to do is write a force equation along the rope. Who's winning? Who's winning? Ashley, with authority in your voice, as though you're confident, as though you are the very voice of God herself. Who's winning? More authority. Like, duh. Yeah. You know what? Or it's not moving at all, but I'll find it's either gravity M2G parallels pulling it down the hill. So Ashley, here is going to be our equation. Anything that ends up pointing down the hill is going to be winner plus. Anything that ends up pointing up the hill is going to be loser minus. Let's walk down this whole rope. So Ashley, if I hear you correctly, you're saying this, yes? Winner. Walk along the rope. What's the next force that you run into that's in the same direction as the rope? Tension, winner or loser? Are you calling me a loser? Oh, sorry, the force. Keep walking. What else do you run in? Oh, I run into tension again, yes? But this time, keep walking along the rope. I run into one more force in the same direction as the rope. What? Loser or winner? Yeah. Ashley, did we write forces from more than one mass? Say yes. Then we better have more than one mass over on this side as well, the mass of both. Or the mass of all, or M1 plus M2 times A. Spa treatment all over again, losing tension. Gonna make it brief because that's a big yawn. You good? I know, it's the block after lunch is the tough one. I know. Ashley, you did so good. Let's keep going. M2G parallel. M2G 2 lines. Minus friction. Friction is what times what? I don't know the normal force. Oh, but look. I know another force the same size as the normal force. And we're talking friction on this mass, right? Which force is the same size as the normal force? No trig. Oh, I like that. Don't forget the mu, though. Mu M1G. Ashley, how would I get the A by itself, by the way? Can I do that right now? Because we've written it. Can I go equals A and divide by M? Both. So let's plug and chug. The acceleration is going to be M2. I've scrolled down. What was M2? 9.8. G, also 9.8. That's not confusing. Sine 42 minus mu 0.17. M1, 12 times 9.8, all divided by 12 plus 9.8. What do you get for the acceleration? And this is, again, one more reason why we abandoned up is always positive, down was always, because you can see, Nate, now I've got horizontal and slanty. How do I give that as a direction? I'll just find the magnitude, and I'll interpret direction as I need to, depending on which mass I'm looking at. 9.8 times 9.8, I guess we could have gone 9.8 squared, times the sine of 42, close off the bracket, minus 0.17 times 12 times 9.8, close off the top bracket, divided by, open a bottom bracket, 12 plus 9.8. I guess I could have gone 21.8 in my head. Well, whatever. Double check. Good. Minus good. 2.03079? Yeah? Is that okay, Kelly? Woohoo! Hard Joe, what does B want me to find? Oh, look at one mass. Which one? Doesn't matter, but I bet you one's easier. Which one looks a little nicer, a little easier? Yeah, the non-slanty one. And you know what? Even if tension was a loser, I'd probably still choose to use the non-slanty one because just less trig and I'm less likely to get sine and cosine mixed up and whatever. So looking at mass 1, who's winning? Tension. Who's losing? Oh, good gosh, Mr. Dueck. Now this is becoming like routine. Cool. So it's going to be tension minus friction equals, and we're just looking at one mass. So it's just going to be M1A. In fact, I think it's going to be tension equals M1A plus friction, which is M1A plus mu times the normal force. I don't know the normal force. Oh, but look. In fact, we've already done that. M1G. We did that on the previous to find acceleration, didn't we? So it's going to be M1, 12, A, 2.03, plus mu, 0.17, M, 12, G, 9.8. I think the tension is going to be 12 times that plus 0.17 times 12 times 9.8. Double check. Did I type that in right? That looks good to me. Do you get 44.36? Yeah? 44.4? Or am I, no? Yeah? 44.4? And Claire, I'm going to argue that's not as much tougher, longer. Yeah. Oh, hey, what if we guessed wrong? What if gravity wasn't enough to pull everything down the hill? When I found A, I would have got a negative on my calculator. So that says start over. Oh, but when you start over, you can't just change all the pluses to a minus and all the minuses to a plus. You might have had friction pointing in the wrong direction because you thought everything was moving to the left and you would have pointed friction to the right. But actually it's moving to the right. Then you might have to point your frictions. You might have to quickly scribble out your free body diagram and make a small adjustment. But it's pretty minor. Everything else will be in the right place. So example 2 said, how would you determine the direction this system moves? How would you figure out the direction that this moves? Well, what are the forces acting on little m? Get the obvious one. Little mg and tension. What are the forces acting on big M? Get the obvious one. Big mg. Normal force, tension, but I would break this up into perpendicular, parallel, and I should use a capital M here, shouldn't I? Hey, looking at this, can you see what happens to the tensions? What happens to the tensions? They cancel. You know what? The tensions aren't what makes this system decide to move. And I'm going to argue, Michael, that the normal force and mg perpendicular cancel each other out. Do you know what two forces are tugging in opposite directions here? Little mg down and what? Hakeem. Big mg parallel. So it says, how would you determine the direction this system moves? Which is bigger, little mg or big mg parallel? Which is big mg sine theta. That's the mathematical approach. If you want to know ahead of time which one is your winner, I guess. I'll be honest. I usually just make an intelligent guess. And if I'm wrong, how do I know? I get a negative acceleration, but it's such an easy fix to go back that I almost never bother crunching this ahead of time to find out. I just kind of, I'm pretty sure it's moving that way. Look at example 5. Sorry, example 3. It says find the acceleration. Now, first of all, Neve, if the 8 was right here and the 5 was here, this would have to be winning because the 8's got all of gravity pulling it down and it's the larger mass. But that's not what they did. They got a lighter mass, but it's hanging over a cliff. They got a bigger mass, but it's going down a hill, which means it's not getting the full component of gravity. It's going to be getting some kind of a component. Who's winning? Usually stuff hanging over a cliff, I think. So although I could find this out, I could probably say, hey, 5 times 9.8, that's what's pulling down. 8 times 9.8 times 2 lines is sine 30. That's what's pulling down. I would probably just guess the 5. However, on purpose, I want to show you what happens if you guessed wrong. Let's suppose, Race, you said, the 8's bigger. It's winning. Easy fix. So we're going to do it wrong, and then we're going to correct. Right, Johnson? Yeah. You awake? I don't think you are. Okay? Hey, suggestions, besides smacking him upside the head. Suggestions. Yeah, let's label our forces, free body diagram, whatever you want to call it. The 5 is pretty easy. I'm pretty sure the 5 is going to be M1G tension. And let's pretend, so I'm going to make a little note here, assume 8 kilogram is the winner, which, Kelly, is reasonable because some non-physics people would just say, oh, the heavier mass obviously is going to be the winner. And I just showed you it turns out it's not going to be. But I want to show you that it's not the end of the world if you guess wrong. So you would go M2G, yes? Tension. Hey, if mass 2, if the 8 is the winner, which way is it sliding? Up the hill or down the hill? If it's the winner, if you guessed that it was the winner, which way would that 8 be sliding? Up the hill or down the hill? Down the hill. So which way would friction be? So you would say, okay, this is wrong, but we're going to do it wrong to show you it's a really easy fix. Oh, and there would be a normal force, yes? Now what would you do? Begins with letter C and rhymes with components. Okay, we would break up into M2G perpendicular and M2G parallel. You would say, what's winning? Oh, the parallel gravity component of mass 2 is doing all the work. So you would say, down the hill is going to be a winner. And you would say, my equation is going to look like this. M2G parallel. And then you would say, okay, I got tension up the hill. I got friction up the hill. Both losers. But this tension, when I follow it, ends up going down the hill. So I run into another tension. Turns out to be a winner, which I kind of expected because tension is canceled every other time. Oh, and then I run into M1G, which when I follow it ends up pointing up the hill. So M1G, loser. And that equals the mass of both times A. You probably relax, Cliff, and lose some tension. Yes? And then you'd say to yourself, M2G parallel. Oh, did I say parallel? Is that 2 lines? Sine, right? So you'd go, this is going to be M2G sine 30 minus, Jordan, friction is what times what? I don't know the normal force. Oh, but look. Another force the same size as the normal force. Which one?
M2G
Perpendicular, which is cos. By the way, I don't care if you say it wrong as long as you write it right. Right? Right. Okay. And then you'd go minus M1G. By the way, you'll notice the masses don't cancel this time because I don't have an M2 in everything. I don't have an M1 in everything, so masses this time don't cancel. How would I get the A by itself? Really? Okay, so I'm going to do that on this line as well. Divide by M1 plus M2. And again, Bree, we've guessed wrong, but I want to show you, it's an easy fix. We plug in our numbers, right? So we'd say M2, 8, 9.8, sine 30. You know what? Running out of room here. I don't need to go down a line. A equals, we plug in numbers, M2, 8, 9.8, sine 30 minus mu 0.05, 8, 9.8, cos 30 minus 5 times 9.8, all divided by 13. Right, Ashley? And again, I think you've heard me say, friction doesn't make this as much tougher, a little longer. Okay, fair enough. More typing. I would definitely put the top in brackets. I would go, okay, 8 times 9.8 sine 30 minus 0.05 times 8 times 9.8 cos 30 minus 5 times 9.8. Yep. Just close off one bracket, right, Mr. Dueck? Divided by, double check. It looks good. 13. Ah! Kelly, how do I know I guessed wrong? Okay. No worries. So who's really winning? Winner. Loser. This is sliding up. Which force do I have pointing the wrong way? So I would go yoink. And I probably wouldn't even bother erasing it. I might have, but you know what? I probably just cross it out like that. I'm in a rush, but that's clear. I think all the rest of my forces, though, are good. Now I got to adjust. It's going to be a strange order, but mass 2 parallel. Is it a winner or a loser? Loser. 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 Right? Just put a negative in front of it everywhere you see it. Oh, then I ran into friction. Now I got to be very careful. Which way is friction, a winner or a loser? Remember, I flipped it, but I've also flipped the winner. Is friction a winner or a loser? Yeah, it's still a loser, isn't it? So, did I call it a loser before? Good, good, good. Don't even need to fix that. What about M1G? Winner, winner, winner. In fact, Mr. Dueck, I think you can just go like this and do a little bit of tweaking. I think you're going to go put a negative right there. That's good. And a positive right there. So, Sammy, for making such a monumental mistake of wrong way, the fix is so easy. This is why I almost usually don't bother calculating who the winner is ahead of time. I find it takes less time for me to fix it after the fact than to try and predict it ahead of time. It's up to you, Michael. You can calculate it ahead of time. You can try and figure it out. 0.492, it's almost a tie, but not quite. 0.493. Is that right? Anybody else? Double check me. What did that correction take? 30 seconds to explain to you, but in real life, probably 10. Meh. A equals 0.493 meters per second squared. Hey, what does B want us to find? Tension. What would be the easier mass to look at to find tension? Mass 1. Who's winning in mass 1? Now, turns out M1G minus tension, right? So it's going to be B. M1G minus tension equals M1A. Is that okay, Peter? I think I would go plus that to that side and minus that to that side at the same time. And I think I'd get this. Tension equals M1G minus M1A. And I hope what you're also seeing here, Claire, is this is why I've emphasized the setup so much. You do a good free body diagram, you get that first equation even wrong, but mostly correct. You're almost home free as long as you keep your eyes open and recognize what nature is telling you with certain answers on your calculator. Tension equals, what was M1? 5? 9.8 minus 5 times 0.493. 5 times 9.8 minus 5 times, I'm going to use the answer button. And I get a tension of 46.5 newtons. Turn the page. Example 4. Oh, last one. Good. By the way, after today, technically, we're done the unit. I'm going to be doing lesson 8, just looking at a few obscure, weird examples. But if you're wondering, your test's probably going to be towards the end of next week. The only problem is my other Physics 12s are like 3 blocks behind you, and they're getting hit by the Remembrance Day assembly as well. So we'll see. I may go into a stall with you guys and just do lots of review until they catch up, but I don't know. Otherwise, it's like I'm doing 2 different after-school tutorials. It doesn't work very well, but we'll see. Read example 4. Example 4. Which way are we accelerating? Upwards. Which mass is accelerating upwards? Mass 1. So mass 2 is winning. Actually, mass 2 G parallel is winning. Oh, and they told me the acceleration. What didn't they tell me? What do they want me to find? Tension and? Okay, this is doing everything completely backwards. Instead of looking at both masses, writing an equation for everything, find acceleration, find tension. Now I know acceleration. Let's see if we can go backwards and find tension and find a missing mass. We're going to start out the same way. Guess. Free body diagram. M1G tension. Oh. M2G. Ashley, are you wondering about something? Is something bugging you? Because I forgot to put something in this diagram. Did you catch it? Yeah, I just realized I forgot. Let's go with a good old 28 degrees. So, 28 degrees. What other forces are acting on M2? I think there's a normal force. You could call it normal force number 2 because it is mass 2, except is there any other normal forces? so I'm kind of lazy. Which way is mass 2 moving? So which way is friction? So I'm going to have tension, and I'm going to have friction. And I'm going to go M2G perpendicular and M2G parallel. Now, normally, Callum, I'd say, who's winning? I got the acceleration. What does part A want me to find, Callum? Go look at one mass. Although, if you look at one mass, in one of them, you'll know everything you need. In the other one, you don't know everything you need. Which mass would I look at to write a tension equation? Mass 1 or mass 2? Mass 1. Why? I don't know mass 2. That's the other thing they're going to ask me to figure out. Okay, I think I can. I think. So it's going to look like this. A. Mass 1. Who's winning? Tension or mass 1? Tension minus M1G equals M1A. Tension equals M1A plus M1G. I scrolled down. What was mass 1? 8. What was A? 2.1? No? Yeah? Plus 8, 9.8. Eight times 2.1 plus 8 times 9.8. 95.2. Anybody else? Yay, that wasn't too bad. Again, how did I know that I was approaching this one backwards? Because in every other question, the first thing we've done is find the acceleration. And I hope you noticed in this question, they gave it to us. Claire, what do you want me to find in part B? Let's write an equation for mass 2. And I think we'll be okay. I hope. Claire, is mass 2 moving up the hill or down the hill? So if it's moving down the hill, which force must be winning if it's accelerating down the hill? Which is the force that's pulling everything down the hill? It's got to be M2G parallel because that's the only one pointing down the hill. So I'm going to write an individual force equation. Why? Because they're wanting me to find a mass. So I'm not going to look at both masses. And it's going to look like this then. Winner minus loser equals M2A. Right? We're looking at one mass now, the mystery mass. M2 two lines is sine minus tension minus friction is what times what? Y. That's mu times, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. M2G perpendicular, which I think is cos. Manisha's nodding. Manisha, how many M2s are there in this question? Did you say 3? Of course, you said 3, right? One in the first term, one in the third term, and then one on the right-hand side. Let's get them all to the same side. So I'm going to drop the negative tension down. And I'm going to say this is M2A minus M2G sine plus mu M2G cos. Manisha, how many M2s are there? 3. How many would I prefer? 1. It would be wonderful if there was some kind of a grade 9 mathematical operation that I could pull out of my back pocket and somehow turn this from 3 M2s into one single solitary M2. And there is. Is there an M2 in everything on the right-hand side? What did you call it in grade 9 when you had a variable in every single term? Curtis? GCF. I can factor out a GCF. Now when I do that, I'm going to get this. Negative t equals, I'm going to factor out an M2. Curtis, what's left behind in the first term in brackets? And then a minus, then what? And then a plus. Hang on, trying to get it to right here. Plus mu g cos. How would I get the M2 by itself? Divide by that mess. Which again, have you heard me say, it's not as much, it's longer. I don't know if it's that much tougher friction, but it's long and ugly, but not too bad, I think. I think M2 is going to be negative tension, all divided by A minus G sine 28 plus mu G cos 28. Let's start plugging in numbers. Negative tension, what the heck was tension? Oh. Negative 95.2. All divided by A was 2.1? Yeah? Minus 9.8 sine 28 plus, what was mu? 0.05? 0.12, sorry. 0.12, 0.05, I think was the last question. 0.12, or a couple of questions ago. 9.8 cos 28. Okay, I can type this. Negative 95.2 divided by bracket 2.1 minus 9.8 times the sine of 28 plus 0.12 times 9.8 times the cos of 28. Close off the bottom. Oh, my 95.2 didn't show up, did it? Insert a 2 right there. Negative 95.2, this is lots of typing. Sine, I think, to get a mass of 65.1. Woohoo! Oh, mass. Units, don't you dare say newtons. Kilograms. I almost started to write newtons, I was so used to it. My point here, Sam, is the method that I've shown you can find anything that you're missing in the winner minus loser equation. Oh, and if it's a mass, a little trickier, but still doable. What's your homework? Number 1, you gonna make it, Jordan? You guys are looking all dead. Okay. By the way, I gave you 2 coefficients of friction here because it's both moving and standing still, but they're the same, so we're pretending that there's one type of friction. Two is a good thought question. Boy, that's finding a mass again. That's a pretty nasty one. Let me see here. Let's go 4. 7. And 8. Is there a 9? Nah. Nah. I'll stop there.